Last week in class we discussed the limit definition of derivative. As we talked about last week, it's f prime of x is equal to the limit as the change in x approaches 0 of the function x plus change in x minus the function of x. And all this is being divided by the change in x. This limit, however, is time consuming. It often takes a long time to find simple derivatives, especially for things such as exponential functions. You also have homework, section 4.3, numbers 1, 2, 3a, 5, 8, 10a through c, due next week. However, today we're going to talk about the power rule. It'll be on page 108 in your textbook, and it's really focusing on how to take derivatives of exponential functions in a much quicker manner, avoiding the limit definition. The general form of the power rule is f of x is equal to a times x to the b power. This then yields the derivative of f prime of x is equal to a times b times x to the b minus 1 power. Let's go ahead and do a few examples. The first example is f of x is equal to 6x cubed. In this case, f prime of x, or the derivative, will be equal to a times b of x to the b minus 1 power. This then simplifies to 18x squared. However, that's always the case. Sometimes we have powers that are less than 1, or fractional powers. Does it still hold true? Let's go ahead and find out. For this example, we have f of x is equal to x 3x to the 1 half. F prime of x will be equal to a times b once again times x to the 1 half minus 1 power. This then simplifies to 3 halves times x to the negative 1 half power. As you may recall from your algebra class, this then can be re-simplified to 3 over 2x to the 1 half. Now we put this in radical notation, it would then yield 3 over 2 square root of x. This is the final answer. This is the derivative using the power rule. If you have any questions, please feel free to contact me during my office hours, or as always during class.